All right, today we're going to talk about prime factorization, and I'm pretty sure that most of you have a good understanding of prime factorization based on what you did in 6th grade. So I thought that this would be a good lesson to do over the e-learning break, since you do already have some experience with prime factorization. So first off, what is prime factorization? Well, it's writing a composite number. So remember, composite means more than 2 factors. Writing a composite number as the product is an answer to a multiplication problem, of its prime factors. For instance, the number 60 is a composite number, and we could get 60 by doing 2 to the second power times 3 times 5. So what this really means here is 2 to the second power is 2 times 2 times 3 times 5. And if we were to work that out, 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. Notice how I used exponents for any prime number that repeated more than once, and I also listed my prime numbers in order from least to greatest. So how do you know how to do this? Well, you use something called a factor tree, okay? So the way that you make a factor tree is you can only do 2 branches at a time. So we're going to start like this, and we want to think about 2 factors of 60. Now, we have a lot of choices, okay? 60, you could do 1 times 60, you could do 2 times 30, you could do 3 times 20, you could do 4 times 15, you could do 5 times 12, you could do 6 times 10. Wow, lots of choices here on what we could choose for our 2 numbers. Now, there's only one choice that you definitely do not want to use, and that choice is this one, 1 times 60. Remember, 1 is not a prime or a composite number, so we do not want to use a 1 in our factor tree ever. You should never see a 1 show up in your factor tree. So this pair is gone. That means we have 5 other choices, and there's not one choice that's better than another. Now, me personally, my preference, whenever I see a number that ends in 0, I think, ooh, I can do 10 times something to get that number. So I always use 10 times, in this case, 6, okay? But these other 4 choices would have been just fine. All right, now that we have our 10 and our 6, I'm going to think about, is 10 prime? And no, 10 is not prime. So I'm going to do a tree off of the 10. And is 6 prime? No, 6 is not prime either. So I'm going to do a tree off of my 6. Now, if you struggle with this, remember that you have this chart here that we talked about the other day, where you have your list of prime numbers, okay? So that's the list that we need to use, and hopefully you either have that chart or you just wrote down the prime numbers in your notebook. Okay, so since 10 and 6, neither one of them are prime, I'm going to have a tree off of them. For 10, so remember you have the choices 1 times 10, 2 times 5, but we cannot use a 1 in our factor tree. So that means our only choice is 2 times 5. Now, does it matter if you put 2 times 5 or 5 times 2? Absolutely not. For our 6, we have 1 times 6 and 2 times 3. Once again, can never use a 1 in a factor tree, so that means I have to use 2 times 3. Or you could have wrote 3 times 2. It really wouldn't have mattered. Okay, now that I have these numbers, I need to think about, is 2 prime? Yes, it is. So I'm going to circle it. Is 5 prime? Yes, it is. So I'm going to circle it. Is 2 prime? We already said yes. And is 3 prime? Yes, it is as well. So by circling the prime numbers, it does 2 things. One, it tells me stop. Your tree cannot continue off of that number. And the other thing it does for me is it lets it kind of stand out in my tree. All right, so I have 4 prime numbers here, 4 prime numbers, and I'm going to write these 4 prime numbers in numerical order from least to greatest. 2 times 2 times 3 times 5. So you definitely want to write them in order from least to greatest. And our very last step is going to be to write any number that repeats with exponents. Since I have two 2's, I'm going to write 2 to the second power times 3 times 5. And that's it. There is our prime factorization of 60. Okay? All right, let's do some more practice. All right, so for the number 12, I have 1 times 12, I have 3 times 4. We know we can't use 1 times 12, so I'm going to use 3 times 4. 3 times 4. Then I ask myself, is 3 prime? Yes, circle it. Is 4 prime? No, it is not. 4, 1 times 4 or 2 times 2. Remember, I can't use 1 times 4, so I'm going to have to use 2 times 2. Is 2 prime? Yes, it is. This 2 is also prime. So I'm finished. I have stops everywhere. I cannot continue the tree. So I have 3 prime numbers here. 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. I'm good. I'm now going to write this with an exponent. 2 2's times 3. And I don't care if you use that multiplication symbol or if you prefer this multiplication symbol. It really doesn't matter at all, okay? Sometimes you'll see me switch back and forth because it really, I don't have a preference at all, okay? So either way is fine. All right, how about the number 45? Why don't you pause the video and you try the number 45, and then once you have your answer, go ahead and hit play and see how you did. All right, so for 45, we have some choices here. Again, 1 times 45, we have 3 times 15, and we have 5 times 9. You cannot use 1 times 45. So that leaves you with 2 choices. Now, you could have used either one of these. In fact, I'll probably use them both so that you can see that they both work. So let's start out with the 3 times 15. Maybe that is what you chose. Now, you should have asked yourself, is 3 prime? Yes, it is. Circle it. Is 15 prime? No, it is not. So 15, I can do 3 times 5. And 3 is prime, and 5 is prime. So I have 3 times 3 times 5. Again, that's 9 times 5. So 3 to the second power times 5. Final answer. Now, I said that I work it out the other way as well because maybe you did not choose 3 times 15. Maybe you chose 5 times 9. You chose 5 times 9. 5 is prime. You should have circled it. 9 is not. 9 is 3 times 3. 3's are prime. So we have 3 times 3 times 5. You can see we end up with the same factors. We have the same factors. So 3 to the second power times 5 is our final answer. So these trees look very different, but again, it's going to give us the same answer. So it's going to be totally your choice on what you choose to use. Just remember, you can't choose 1 times 45. That will not work. All right, let's try 64. 64. So again, go ahead and pause the video and you try 64, knowing that your tree might look a little bit different than mine, okay? All right, so for 64, lots of choices here, but I'm gonna use 8 times 8. Because when I think of 64, that's the first thing that I think of, is 8 times 8. Now, 8 is not prime. 8 is 4 times 2, or 2 times 4. 4 is not prime, but 2 is. 4 is 2 times 2. And 2's are prime. Now, what's nice about using 8 and 8 is this side of the tree is going to look exactly the same as this side of the tree. So I'm only doing really half of the work here. So again, 4 times 2. 4 is 2 times 2. Wow, you have a lot of 2's going on here. So that is one of the reasons it's nice to circle those prime numbers so that they kind of stand out once again. So we have 1, 2, 3, 4, 5, 6. So 2 to the 6th power would be your final answer. All right, and let's do one more. Let's do this really big number, 1,200, 1,200. Okay, well, I see that it ends in 2 zeros, so that means I can do 100 times whatever's out in front, 12. I just made this problem a lot easier now. Now, 100 is definitely not prime, and neither is my 12. So I'm going to focus on my 100 right now, then I'll go back over to my 12. So for 100, how about 10 times 10? Neither one of those are prime either. 10 is 5 times 2. Both of those are prime. So again, 10 is 5 times 2. Both of those are prime. Let's move back over now to our 12. So our 12, let's do 4 times 3. 3 is prime. 4 is 2 times 2. So really, even though 1,200 is a big number, our tree is not that bad. Be very, very careful when you are writing these numbers out that you don't miss anything. So I'm going to focus on my 2's first. I have 1, 2, 3, 4 2's. Next, I see that I have a 3, just one of them. And then I notice that I have 1, 2 5's. All right, so we're going to have 2 to the 4th power times 3 times 5 to the 2nd power. And you are finished. All right, so hopefully that was a good review of prime factorization. Remember, final answers, you need to use exponents, and your prime numbers should be in order from least to greatest. If you get stuck on your prime numbers, just refer back to the hundreds chart where we identify the prime numbers. And if you need to, you can rewatch the video about what numbers from 1 to 100 are prime.